Hi, I'm Evelyn, working on the Maillard reaction and meat flavor development. There's one chemical reaction that we all carry out on a regular, maybe even daily basis when you cook a range of foods. It makes steaks mouth-watering, bacon smell amazing, and almost every other cooked food tastier too. Let's get to know one of the world's most delicious chemical reactions, the Maillard reaction. It takes its name from French chemist Maillard, a physician who never worked on food. In 1912, he published a paper trying to explain what happens when amino acids react with sugars at elevated temperatures. Long after he died, it was realized that almost all the meaty flavors that develop during cooking are caused by the Maillard reaction. The reactions are very complex, and the details are by no means understood today, despite many chemists devoting their lives to the study. The complexity comes from the fact that there are many different sugars and amino acids that can react together, and from the fact that the actual reaction products depend on the temperature, time, moisture content, acidity of the environment, and the other chemicals that are nearby. For example, the process is accelerated in an alkaline environment, as the amino groups are deprotonated and hence have an increased nucleophilicity. The first stage is being the reaction between the reducing sugar and the amino acids. This produces a glycosylamine compound, which in the second step rearrange to produce a ketoamine. The final stage consists of these compounds reacting in some ways to produce several different compounds, which can themselves react to produce further products. Eventually, you get to a flavor tone. Controlling the Maillard reactions is a tricky business. However, a few simple guidelines that can be helpful. The reaction was best somewhere between 250 and 300 Fahrenheit degree. In this range, the chemical reactions are faster, and the heat evaporates excess water, causing browning noticeably within minutes. Another important point is that as the temperature rises above 330 degrees, increasing the caramelization, the use of sugars and salts inhibit the Maillard. At very low temperatures, Maillard reactions are often secondary to other processes such as enzymatic browning.
Hi everyone, myself Samneek Kaur. Today I'm going to discuss with you the Maillard reaction mechanism in meat. As we all know that Maillard reaction is a reaction between amino acids and reducing sugars. So when meat is heated, the building blocks of proteins, that is amino acids, will react with naturally occurring sugars in meat. This will result in the formation of Schiff base with the elimination of water molecule. The product is known as N-substituted glycosylamine. Now, this Schiff base will isomerize and will produce amodary products such as 1-deoxyozone, reductone, and 3-deoxyozone. All these reactions are also known as early Maillard reactions. Now, next is the advanced Maillard reaction, which will produce the resultant compounds that are responsible for meat aroma. In this step, the compounds produced above will undergo fission, dehydration, and Stecker degradation. Fission results in the formation of diacetyl pyrovaldehyde. Dehydration produces maltol, isomaltol, furfural, etc. Stecker degradation is one of the most important reactions, which involves oxidative deamination and decarboxylation of an amino acid in the presence of dicarbonyl compound. This produces Stecker aldehyde, which includes acetaldehyde, 2-methylpropanol, 3-methylbutanol. In case of meat, the amino acid cysteine is well-known precursor of meat flavor, which results in the formation of acetaldehyde. So, all the resulting compounds that are formed from the above reactions will impart flavor to the meat or meat products.
Hi everybody, my name is Saili and I'm going to talk about aroma compounds present in cooked meat. So, which is your favorite meat? Chicken, lamb, beef or pork? How do you identify whether it's the meat that you want? Why the aroma of the grilled meat and moiled meat are different? It's because the aroma compounds present in the meat and the way it's cooked. Two thermally induced reactions takes place in meat. One, the Maillard reaction, and the second, the degradation of lipids. In Maillard reaction, heterocyclic compounds are formed. N-isoheterocyclic compounds, pyrazines and sulfur compounds, these both dominate. Other compounds such as pyrols, furans, thiophenes, imidazoles, thiozoles, oxazoles, cyclic ethylene sulfides and pyridines are also present. These are all the classes of the meat flavor compounds present, but today we are going to talk about only two major classes. These are the two major compounds present. In roasted meat, pyrazines, and in boiled meat, sulfur compounds are responsible for the aroma. Let's jump onto our first class of compounds, that is pyrazines. Pyrazines in meat outshines all the above mentioned groups because of its sensory and structure variety. These are the major class of volatiles produced from Maillard reactions. Important factors affecting the formation of pyrazines are temperature, cooking time, moisture content and pH. There are many pyrazines, out of which alkyl pyrazines as well as two classes of bicyclic compounds, that is 6,7-dihydropycyclopyrazine and pyrrolopyrazine are found in volatiles of meat. They are produced in Strecker degradation reaction, as you can see in this slide, by condensation. Recent study states that 3-deoxyglucosone is a main precursor for the formation of pyrazine. Next class of compounds are sulfur compounds. Aroma of meat would have been completely different without sulfur compounds. Some properties of sulfur compounds are: it has a low threshold, low concentration, it's very reactive, it easily degrades, and it's a key volatile found in meat. It is a precursor used in the manufacture of synthetic meat flavor in industries. These are some of the sulfur aroma compounds present in meat. Are they found in roasted meat? No, but in boiled meat. Volatiles like sulfides, disulfides, aliphatic thiols, and heterocyclic compounds found with 1, 2, or 3 sulfur in 5 or 6 membered ring are found in boiled meat. Hence, based on the reviewed literature, we can say that Maillard reaction is responsible for the boiled, savory, and roasted meat flavor.
Hi, my name is Chinmay Kadam and my topic for today is synthetic flavors from Maillard reaction. The idea of synthetic flavor in meat was developed by flavor industry. Synthetic meat flavors are formulated to impart flavor in the meat while cooking. Most of them contain precursor of Maillard reaction that results in the meat flavor. Thus, Maillard reaction play an important role in the development of synthetic meat flavor. Development of synthetic meat flavor was one of the commercial use of Maillard reaction in the food industry. Synthetic flavors for pork, beef, ham and chicken with genuine meat character are now available in the market. As discussed earlier, Maillard reaction is the reaction between amino group of amino acid and carbonyl group of sugar to give various products. The three pathways involved in flavor development are: first, condensation and enolization to form furfural compounds. Second, formation of amidori rearrangement products. And third, both pathways leading to stacker degradation of alpha amino acid. The first two pathways are important as they lead to the formation of flavored compounds formed from carbohydrates, and amino acid acts like catalyst. One of the example of Maillard reactant that has role in meat flavor formation is cysteine and its dimer cysteine. When Maillard reaction with cysteine as reactant take place, stacker degradation products are formed, and the interaction between these products and with other products take place forming flavor of meat. Another amino acid involved in roasted meat flavor is glycine. When glycine reacts with sugars, amidori rearrangement products are formed due to Maillard reaction. Out of these products, 94 are volatile compounds, and of that, 50% are pyrazine derived compounds, which actually gives the roasted aroma to the meat. Other products formed during Maillard reaction that form flavors are acetaldehyde, mercaptoacetaldehyde, hydrogen sulfide, etc. Recently found amino acid involved in the meat flavor development is thiamine.
Hi, this is Aishwarya Kamble. My topic is significance of Maillard reaction in meats. The first significant property of Maillard reaction is that it acts as a source of flavor. The delicious flavor of brown meat is a result of Maillard reaction. It is triggered by heat. This chemical reaction combines sugars and amino acids to create thousands of different flavor compounds. The Maillard reaction has received much attention since the 1950s as the source of flavor chemicals in cooked foods. The major flavor chemicals are nitrogen and sulfur containing heterocyclic compounds. The sulfur containing thiopenes and thiozoles give a characteristic cooked meat flavor. Most of the beef is cooked using a direct heat source leading to either the Maillard browning reaction or caramelization reaction, which actually gives the unique flavors. An experiment was carried out to determine the significance of browning reaction and caramelization on sensory evaluation of beef flavor. It was observed that direct heat cookery increased the sensory beef flavor and juiciness. However, increased quality grades positively influenced all the sensory attributes. Another significant role of Maillard reaction is that it acts as a contributor for aroma. Aroma is a crucial property of meat. It is the most important property in the identification of meat samples from various animal species. The Maillard reaction and stacker degradation are important contributors to the aroma of cooked meat. Now we'll see the effect of aging on Maillard reaction. An experiment was conducted to show the effects of aging on volatile compounds from Maillard reaction. It was seen that aging of meat followed by cooking at 180 degrees Celsius leads to a statistically significant increase of benzene acetaldehyde and heterocyclic compounds including 2-formylfuran pyrazine, 2,6-dimethylpyrazine, 2,3-dimethylpyrazine, 2-acetylthiazole, and 2-formyl-3-methylthiophene. These compounds are known to play an important role in the aroma of cooked meat, and increases in the number of precursor amino acids as well as hexoses and ribose during storage were reported previously, indicating that aging is important for not only the taste but also for the aroma of the cooked meat. In conclusion, it can be said that Maillard reaction in a proper way is important for meat flavor development. Thank you for watching our video.